Hi, my name is Netia McCray. I'm a recent MIT graduate as well as the manager of Fab Lab Roxbury and entrepreneur in residence through my company Bajika here at the Roxbury Innovation Center. And what I'm here to talk to you guys about is the importance of fabrication laboratories, also known as Fab Labs, in terms of pursuing entrepreneurship and turning your idea into reality. So all of you, if you're a disciple of entrepreneurship, know about the Lean Startup Method. And the Lean Startup Method has this thing called BML, which predecesses that everything has to be, you build something quickly, you measure it, you learn from it, and you continue to do that till you build an awesome project. Someone will say one that kicks butt in the marketplace. However, in order to go through this cycle, it requires you to build something. And what we like to say in Fab Labs is the purpose of a fabrication laboratory, if you're interested in hardware or consumer products, is we take this BML philosophy and we turn that into build, make, learn. Only thing we change is the measure, because the purpose of this BML is to actually turn an idea into an actual sketch and an actual prototype. And from your prototype, you can ask questions, get answers, feedback, and repeat with the new ideas that you want to formulate based on you going through this the first time. So if you're an entrepreneur, the best way to go through this build, measure, and learn cycle is to actually try it with something a little smaller, which is build, make, learn, especially if you're in hardware or consumer products. Netia McCray, and BML, or build, measure, learn, is the principle that is used in the Lean Startup Method to tell you how you should go from what idea, create a rough prototype, and then learn from that prototype. We take that same measure in Fab Labs and we called it build, make, learn, meaning you take your idea, you go through the process of making it come into reality via a prototype, and then you use that prototype to get feedback. Now, when you think fabrication laboratory, you usually think hardware or physical prototypes. While if you're building mobile applications or software, you're mostly focused on the actual digital, virtual reality type of stuff. So the comparison between hardware, I like to call it, and software are actually quite similar. In fact, build, measure, learn, and build, make, learn are basically the same way of saying the same thing. When you're building a computer application, whether it's mobile, whether it's software, what have you, you still have to start with an idea. What do you want it to actually do? Then you release it once you build a prototype or a minimum viable product. Then you want to measure via various metrics, such as user retention. Are people still on their app playing with it? And whether or not it actually fulfills the purpose of your idea or the challenge that you're trying to solve via your app or your software. Once you measure those metrics, you learn what motivates your customer. Once you learn that, you go back with a new idea on how to improve that mobile application or piece of software. And that's how you do the Lean Startup BML, which is more towards the software aspect, using the principles from the Fab Lab, which is build, make, learn, or BML. So this is our first SLA 3D printer. SLA means it uses a resin in order to actually create the 3D print. This is Fab Labs, which is Massachusetts' very own 3D printing company. And all of the equipment you see here actually is related to the Fab Labs 3D printer and allows for you to take your print from resin to being processed to actually being sterilized. Next, we have the Cindo 3D printer. It is known as an FDM 3D printer. So this one doesn't use resin. It uses basically PLA or ABS plastic. And what it does, it actually deposits it on layer by layer. So unlike it rising from the goo in the Fab Labs, you have this one building prints layer by layer, which is similar to how a desktop printer works. The Ultimaker that we have here follows the same process, in which you have these rolls of 3D print filament right here that you actually load up in the machine, and you can add layer by layer the plastic in order to create a three-dimensional design. Over here we have our vinyl cutter, which allows for us to make stickers and other decals using vinyl. We can also make some really cool things using copper paper and vinyl, such as little circuits that kids can interact with once they put a power source to it. Last but not least, we get to our other area of the Fab Lab, including our Cnc Mill. Our Cnc Mill allows us to mill various materials, such as metal, a little bit of wood, such as plywood, which is my favorite, and also we can make custom circuit boards using these little babies right here. So this is our, I like to call it our BB-8 machine. It's our nice little milling that allows us to go beyond just adding layers of plastic, or what we can do with our final machine, which is our laser cutter, which allows us to cut two-dimensional shapes out of pieces of plywood as well as acrylic. As you can see, this is probably one of our most used machines because it allows us to get the fastest prototypes out to our students as well as participants in our space. While the process of going through build, make, learn, or build, measure, learn is very exciting, the most important process or part of that process is going from make or learn or measure and learn back to build. A lot of people get caught up when they do this the first time. They don't feel they need to go back through it. The key part of this cycle is to actually help you refine your idea to the point that you have a killer idea or the unicorn idea. If you only go through it once, how are you refining your idea? As everyone says, it's not your first idea that takes the market by storm. It's the refinement of the idea by going through the cycle multiple times. And I see people, whether it's in software or hardware, time and time again, they only go through it once. So don't just go through it once. Make sure you go through in order to have your idea be refined and be the best it can be. So with Majika, our first product was a portable solar USB charger, and pretty much it was about this big, and it was supposed to be something that once someone assembled it, they were actually able to charge their mobile devices with it. And I thought it was a reasonable size to be this big, but people were immediately like, no, it's too big, no, it's too big. And I'm going, well, I can't find a smaller solar panel in order to use that will have enough voltage and current to power a mobile device. So I'm pretty much stuck like Chuck, like, well, I can make it thinner, but I can't make it smaller. But the more feedback I got that it was too big, the more I was like, okay, I just need to set aside some time and just try to find an alternative solar panel. Maybe it's not something that's on the mass market yet. So I set aside 2 months just going like, should I pay attention to them about this size? Maybe my customer doesn't know what art they're talking about and they've just never had a product like this. They don't understand the design constraints, what have you. A month later, we found a solar panel that was this big. And it still gave us the current and voltage we needed in order to charge a mobile device. And we redesigned the product around that solar panel. And immediately everyone was like, it could be thinner, but other than that, it's awesome. It's the perfect size. I can have it hang off my backpack or purse. I can slide it in my pocket, what have you, to charge my device. And I was like, I was a little frustrated, a little upset people didn't understand that solar panels couldn't be smaller, but it turns out they were right. And not only were they right about my product, but they were right about solar panels in general. And someone answered that call by making a smaller solar panel. Did they know they were helping us? No. But that was us going through build, measure, learn, and not just stopping at what we learned and keep going, but going back to building a new product, and then continuing that 15 more times till we now are at a product that we feel comfortable selling to people and manufacturing not only in Boston, but also in South Africa.